All right, so this is Journal 53. I'm not going to do a bell work here. We're going to go straight into today's lesson. So in this lesson here, we're going to talk about interest formulas. Like, how do we calculate how much interest we have gained over time? Now, this could be a good thing, like you're gaining interest as in you're making an investment and you're producing money from that investment. You probably have heard of those different types of funds where you can make money, or when you put in a savings account, it also grows your money too. Now, the other flip side of it is like things where you take out a loan, like a credit card, a mortgage loan. So when you're buying a house or when you make a car payment and you don't pay it off, you can create something called debt. And that can also be a dangerous thing too. But today I want us to understand the mathematics part behind it. So let's talk about something called compound interest formula. This is actually a really powerful formula, and you'll see what I mean when we start doing some of these problems. Okay, so one thing that I need to go over here is that this is a formula where you have to plug in 4 different items to calculate your total amount. So A represents the total amount that you made over time. Total amount. Where P represents the principal. Principal just means the initial amount. So like if you were making an investment, your initial amount might be like $100. You throw $100 into your savings account, that's the money that you're starting out with. So principal means the initial amount or the money you're starting off with. Interest rate is going to be a percentage. Usually credit cards will tell you like their APR or their annual percent rate is, 24%. I'll make up 24%. Actually, my credit card rate is 24%. That's not totally made up. So interest rate comes in as a percentage. Most companies will advertise it as a percentage. But you need to write it as a decimal when you use this formula. So let's play with that for a moment. If someone said that their percentage was 3%, if you write this as a decimal, you would have to do it as 3 divided by 100 because 3 is out of 100. And if you divide 3 by 100, it's going to be 0.03. So the decimal format is 0.03. Okay, and we would use that as our interest rate. So we want to have it as decimals. And the way you do it is just take the percent and divide it by 100 because there's 100%. Because it's out of 100%. So that's really important. Make sure it's in decimal form. The next thing is compound period. Compound means that basically it's like a verb. When we compound, we add interest to our principal. So what that's saying is like, when you make an investment, they're going to explain to you how often they compound or how often they add interest. So if a company says we compound monthly, that means they're adding interest every month. And you want to compare that to how many times they would compound in a year. So let me use that monthly as an example. If something were to compound monthly, okay, that means that they would compound 12 times a year. So N here would be 12. If they were to compound annually, and this one's more popular, if they compound annually, that means that they're only going to add interest every year. So that means that they're only going to do this once a year. If they were to compound weekly, well, we have to look at how many weeks are in a year. There are 52 weeks in a year, so 52. And then quarterly, think about quarters. How many quarters are in $1? There are 4 quarters in $1, right? So that means they're going to compound 4 times a year. So quarterly is 4 times. And then there's sometimes this word, it's not as popular that we use in math class, but it is actually a more popular word in the real world. It's called bimonthly. A lot of people get their salary bimonthly, means that they get their salary twice a month. So this is usually for minimum wage workers, but usually they get their salary twice a month. So bi-monthly, if you think twice a month in a full year, that's like multiplying how many weeks there are, how many months there are by 2. So that would be 24. So you would compound 24 times a year. So compound is how often you add interest to your principal. So then time is just like how long is the money going to sit in the savings account. And you always want to base time off of years. So the units for time must always be in years, or you can't use this formula. The reason why you want to base it off of years is because these compound numbers are based off of 1 year. So make sure your time is in years. All right, now I want to talk to you guys about another formula, and it's called the continuous compounding interest formula. Now, this one doesn't show up as much in the world because this is the word continuously compounding means like if we were to compound an infinite amount of times, what would that look like? And it turns out when you compound an infinite amount of times, it doesn't make your money grow to infinity as much as I like you to be able to do that, but it actually hits to a limit, and it comes down to this limit called E. So this E is a number we learned last time. It's the 2.718, and it goes on and on and on, just like pi 3.14 goes on and on forever in its decimal values. So just to keep in track here, E is a number, and it's a number we can easily find on our calculators. P and R and T, those are actually numbers you're going to be plugging in, right? P is your principal, R is your interest rate, and T is your time in years. All right, now that we know the definitions and formulas here, let's try out some homework problems. All right, so this is packet 12, page, oops, my bad. This is actually page 4. So in this page here, we're going to be talking about how do you calculate these interests when you make investments here. So let's write in the formulas first. You can see that in the first 2 questions, it's just asking you like, what is the compound interest formula? So that's the A equals P 1 R over N, R being the interest rate, N being the number of times you compound. And then the exponent here is N times T. So number of times you compound with how many years you are investing. And then there's the compound interest formula. So generally you want to use a compound interest formula. You only want to use the continuously compound interest formula when you see the word continuous in your problem. If you don't see the word continuously compounding, you should always be using the top equation. So I'll show you what I mean when we get into some problems here. So this formula is the PERT. You'll hear some college kids and college professors call this the PERT formula because it kind of spells out PERT. So in the first problem here, it says find the balance of the amount after 7 years if 700 is deposited into an amount paying 4.3 interest rate compound monthly. Okay, so here's how we're going to do things. I want you to think about in the story how often they compound first, because that will determine what formula you use. So in this case, you're going to be compounding monthly. And if you compound monthly, well, it tells you how often they compound. They're going to be compounding or adding interest every month, which is 12 times a year. So we know that N, which describes our compound, is 12. If I have an N value, right, I need to use the first formula because this is not continuously compounding. So the first formula is the one that I want to use. So if it's the first formula, I need a P. P here is the principal, the initial amount that I'm putting in the bank, and it's 700. So P here is 700. R here is the interest rate, which is 4.3%. Now, if you take 4.3% and you divide it by 100, it's going to give you 0.043 as a decimal. Also, I want to teach you a trick. One way you can get the decimal very quickly is anytime you divide by 100, you actually move the decimal place 2 times to the left. And so you could also do it that way. But this interest rate here is 0.043, and time here is 7 years. So once you have all these 4 ingredients, you can plug them into your formula. So let's go ahead and do that. And so P here is 700. 1 plus R, which is going to be 0.043, divided by 12, and then 12 times our 7 years. Now, you can do this all in a calculator, and I'm going to show you how you do it on a calculator here. You can also do it in pieces, like you can take this number, divide it, and then add it to 1, and then raise it to whatever this power is, and then multiply by 700. Just follow your order of operations. So parentheses first, exponents, multiplication, division, and then adding and subtraction. Okay? So if you follow order of operation, you don't need a calculator. Well, you do need a calculator, but you don't need like a fancy one like a TI-84. But I'm going to show you how you can do it on the TI-84, so that way you guys know how to use it when you're in class. So I'm going to grab out my calculator here and switch my camera. All right, so I'm going to get this to focus. There we go. All right, so on your calculator here, you're going to be pressing 700 in. So I'm going to type in 700. And then you're going to use a parentheses, 1 plus the fraction. So when you do the fraction, what you want to do is hit the green button, the alpha button, and the y equals button. And then this box shows up. So then you notice that it has the n divided by d, which is numerator divided by denominator, which gives you a fraction. So you're just going to hit enter on the screen. And then when you get to this, the fraction template pops open. So you're going to put in the 0.043 divided by 12. And then you're going to just use notice how I was using my arrow keys to come down. And now I'm going to go to the right to close that parentheses. And then you're going to hit the exponent button, which is underneath the clear button. And then this makes an exponent. So you're going to do the 12 times 7 and then hit enter, and you get the number that you make after 7 years of investment. So it looks like we made $945.34 if you round to 2 decimal places, since this is about money. And we just made, well, if you look at this number versus how much you made already, you made about $245 more than what you had in the bank in the beginning, which is pretty impressive because this person who invested 700 did not do anything afterwards. He just sticked in 700, let it sit for 7 years, and didn't like put in any more money. So keep that in mind. So if a person was a little bit more like suave, he probably would have put in that 700 and maybe put in more money as time went on, which makes the money grow even faster. So that's what a lot of people do who want to save and save really efficiently. All right, so let's do another problem. Let's go into number 4 here. All right, so this is number 4, and you can see here the story says you deposit $2,000 in an account that pays 3% annual interest compound continuously. What is the balance after 5 years? So automatically when I was reading through this, I was like, oh, it's asking for compound continuously. If this is compound continuously, I want to use the PERT formula, or the A equals PERT formula, the compound continuously formula. And to use this formula, you need a P, a principal, which in this case, I believe is the 2,000 because that's how much money you're depositing initially. And R, which is the 3%. So in this case, if you divide 3% by 100, you get 0.03. Remember to write it as a decimal, not as a percentage. That will be you basically be making a lot of money if you just press in the percentage, which then you know it's not true that you would be making that much. And then T is going to be 5 years because he's investing in 5 years. So if you put this all in the formula, so you can put 2,000 e to the r, which is 0.03, times t, which is 5. You're just going to plug this in your calculator. Remember, you need to find the e button. So I'm going to show you how you can find the e button again using your calculator. So I'm going to switch my camera again. Oops. All right, maybe I'll just do it right here. So on the calculator here, I'm going to put in 2,000 first. I'm going to just type in 2,000. There it is. And then what you want to do to get E is you're going to hit the second button, the blue button, and go down on the left side to LN. If you look at LN, you'll notice there's an E above it. And so click the LN button and then the E shows up. Sorry, I'm letting it focus. And then you want to just type in 0.03 times 5 and hit enter. And then there's the amount of money that we're going to make. So I'm just going to pause there. So it looks like we made $2,323.67. So within 5 years of it continuously compounding, we made about over $300 more just with a 3% interest rate. So that's pretty good. And then number 5 here that we're going to do is basically we are investing $2,000. Let me underline that. Into 3 separate bank accounts. So you want to see out of these 3 which one makes the best money. So, so this one, they all have the same interest rate. Okay, they're all 3%. And you're all investing in 6 years of time. What's different here is that you are compounding differently in each bank. So each bank compounds a little different. So first I'm going to write down what I already know. So, oops, I didn't mean to move that. Is there a way I could just move this? Yes, there we go. Okay, so P is equal to 2,200. And interest rate is 0.03 because it's 3%. And T here is 6 years. Now, when we look at these 3 banks, the first bank is compounding quarterly. So that means they're going to compound 4 times a year. Quarterly means 4. Monthly, for the second one, they're going to compound 12 times a year. And bi-monthly, we mentioned this means twice a month. So if you multiply 2 with how many months there are, that's 24. So now all I'm going to do is set this up here. So I'm going to set each of these problems up. If I want to find the first bank, so this is the first bank, I'm putting in $2,200, 1 plus my interest rate, which is 0.03, divided by 4, because that's how often I'm compounding, and then 4 times 6 years that I'm investing. And so if I throw this in the calculator here, let's see what is our investment. Now I'm going to do this to the side so you won't see my camera on the calculator, but if you need to review the other slide, just check and see how I did that in the calculator. Or if you're having trouble, let me know in class. So when I type all of this in here, I get $2,392.83. So that's how much money I made the first time. So in bank number 1, I made $2,392.83. That's when you compound quarterly. Let's see what I get when I compound monthly. So every month I'm making interest. And so I'm going to put in the same values. The only thing that changes is n. So I'm going to change that to a 12 for the denominator and 12 for the exponent. Okay, so if I multiply all of this out, this is going to be $2,393.90. So this is my total amount. And if you really compare this with the first bank, right, you actually made like $1 more. So without doing anything different, you're not making, you're not adding more money to the bank. You're just compounding more frequently. You actually make more money. Now, not a terribly a lot, but you do make some money that is more than the previous. And then this one is bi-monthly. So we're going to be plugging in 24 into the end now. But everything else is going to stay the same. So that's going to be 24. 24 times 6, which is going to give me 23,941.17 if I plug this in the calculator. So that's how much money I made. And this one, I make even like more than the first one here. I make about $2 more, which is not a lot, like I said. But this is you not doing anything. It's the bank compounding more often. So I think for me, I rather choose a bank that's compounding more often so that I know that they're adding interest as frequently as possible. All right, so in this case here, that's pretty much it, guys. I hope this gives you a variety of problems to look at and helps you with your homework. Until next time, guys. Bye.